Good morning, everyone. My name is Dr. Joseph, and I'm a full-time consultant physician at Sundaram Hospital in Trichy. A little bit about myself. I completed my MBBS and MD General Medicine from Christian Medical College, Vellore, and I have done a few certification courses in artificial intelligence. I picked up coding on the way to solve certain problems, and over the last couple few years, I've been building apps using low-code platforms like Flutterflow and extending their functionality using custom actions created by LLMs. So using this process, I have created an app for use within my hospital. It's called the Glycemia app. It was created to remotely manage inpatient insulin advice. So right now it's a standalone app. So I start I started learning Fire so that I can convert this standalone app to integrate with existing EMRs. A lot of things can be populated from the EMRs, and I don't want to recreate everything in the app. So that is the main reason I wanted to learn Fire. So with that, we'll go to the demo part of the app. So the URL for the Fire Challenge app is joseph-firechallenge.flutterflow.app. This is the landing page. So the landing page shows all the patients in the Fire server. Uh, So on, we can create a patient by clicking on this button. You can enter the patient details and the date of birth and the phone number and create. So that creates the patient. So you can see this patient being listed here. So to edit the patient details, you click here and you can edit any of these details and it's stored now. So to view the patient details, you click on this and this shows you the basic patient details. So let's see, since this is a newly admitted patient, they don't have any vital parameters. So we'll see a few patients who have these parameters. So let's take this patient. So the first tab shows the vital signs as a graph format. It includes blood pressure, heart rate, temperature, respiratory rate, and SpO2. The second tab shows you the active conditions sorted by onset date and the current medications which are being given to the patients. And as expected, the app also has a search functionality. You can search for patients in two ways. You can either do a fire query, which I'm doing now. So that is one way, or you can do a simple search, which will search the local app state page state variables. So, so these are two ways of searching the patients. So this is the basic spec we are supposed to develop. So the next part that I developed is the early warning score. So the new score, as we all know, it's National Early Warning Score. It uses a few vital parameters to determine the score. Each component has a score, and the sum of these will determine how sick the patient is. So any score more than 7 is called high risk, and any score less than 4 is low risk. And and each of these risk categorizations has a set of actions that need to be done. So these scores are calculated based on the vital parameters that are being entered. So these are the components of the score. This shows the actual value. This is the actual score. So this is the pulse rate and this is the score for the pulse rate. So this is the reference chart for the scoring system. So the score is calculated when you are adding a new observation. So this is where you add a new observation. Let's enter a few abnormal values. Let's see. So it's being calculated in real time. So this calculates the individual scores. It displays the total score, and it also displays the risk categorization, and it also displays the recommendation that needs to be done. For a high clinical risk, the nurse has to inform the details to the RMO as resident medical officer, RMO and the consultant immediately. The patient's vitals need to be monitored every 15 minutes, and the patient needs to be transferred to ICU and determine immediate medical interventions. So once you submit, this is populated. And when you go back to the patient's list, the patient with the highest score is listed on top. So this dashboard can help you uh, to uh, to decide which patient you need to focus. So you enter a ward for rounds, or it could be a casualty, or this could be any remote monitoring station or anywhere. So how do you decide which patient you want to concentrate? And not all patients are equally sick. So this gives you a quick glance as to who are the sick patients and who you need to spend more time on. And based on the low risk categorization, uh, you can allot your time accordingly. So this is the new scoring system. So now let's go to the next module that I developed. It's called the CBG incident chart. So before we open the incident chart and see what it is, I would like you to first understand the app that I had already developed, the glycemia app, what problem it solves, and how a Fhir implementation of the glycemia app will be better. So here is the sneak peek of my app. So this app has been running in my hospital for the last 2 years, and I've given more than 50,000 insulin advices through the app. So the glycemia app solves for an often neglected aspect of inpatient care. We all know that long-term control of diabetes is bad for the health. We know that it can produce heart attacks and strokes. But many studies have also shown that short-term control of diabetes, especially during inpatient stay, can affect the duration of hospitalization and the outcome of hospitalization, irrespective of what reason they are admitted for. So even if they're admitted for cancer or some infection, if the sugar control during this inpatient stay was good, the patient had good outcome, and if the sugar control was bad, it could lead to prolonged stay and it could lead to in hospital mortality and morbidity. So the glycemia app helps provide this take care of this aspect remotely. The remote management part was especially important during COVID times, and we continued doing it even after COVID went away. So, to show you the quick workflow, this is an example patient which is there in the ward. So, the uh, nurse will first open the case sheet. She will enter the CVG values. Along with the CBG values, they will also enter the a few other relevant clinical parameters like whether the patient is taking well orally, or if the patient is on steroids, or the patient is on inotropes, and if the patient has been taking having insulin infusion or not. And they will also enter the latest creatinine value and the HbA1c value if it was present, and enter the CBG value. And if there's anything else to convey, it will be entered in the nurse notes, and they will click submit. So once it's submitted, the doctor can then open the app, and they will see the CBG values and the clinical parameters associated with it, and the requirements at home. And they will also look at the previous day's trends, This will give them a good clinical context and then decide the appropriate dose for the patient. So, as a helper to the doctor, I have also developed a custom AI model, which I have trained from the data collected through this app. So, it will suggest insulin doses. It's still not clinically validated, still in testing phase. So, this has also been integrated with the app. So, the doctor can enter the advice and either they can uptrate it or downtrate it and then advise the insulin. Then the nurse can open the case sheet. They can see the insulin advice, administer the dose, and then uh, click follow. So this ends the workflow. But before they can even do this, they need to do a specific set of steps. So first thing is, since this is a standalone app and it's not integrated with any existing EMRs, first they have to add a patient to the app if the patient is not already there. They have to enter these details and add the patient. Then after that, they have to admit the patient. And at the time of admission, they have to enter all these details, enter the IP number, which consultant they are admitted under, which ward, which block, which ward, what type of diabetes patient has been having, the duration, what medications they've been taking, their vital stats, their height, weight, BMI, the HbA1c. So all these details need to be entered by the nurse at the time of admission. And along with that, they'll also have to enter these clinical parameters, clinical and lab parameters, every time during CBG entries. So, so this is where Fhir implementation will make things better for the app. So as you can see, a lot of these details can be pulled from the existing EMR itself. Name of the patient, the UHID, the block ward, the latest HbA1c, the conditions of the patient, the home medications. All these could be extracted directly from the EMR itself. So that's what my Fhir app is trying to do. So we'll go to the Fhir app that I have developed. So when you open the incident chart, it gives a similar picture, but these are not all been entered manually. These have been pulled from the EHR data itself. So the ward and everything has been pulled up. Some data might be missing, like the home insulin requirements and the home medications that the patients are taking might not be there. It can be manually added as a medication statement. But the height, weight, BMI, the duration of diabetes, the HbA1c, age, and the conditions of the patient, all these are all pulled directly from the uh, Fire server itself. And it also has a similar view. You can see the previous day's trend. And when the nurse is entering the CBG values, here again, they just have to enter only one parameter manually because the feed status of the patient is a subjective assessment by the nurse, and that is the only one thing that has to be entered manually. The steroid status can be pulled from the IPK sheet where the patient is receiving inotropes like noradrenaline. It can also be received from the IPK sheet, latest HbA1c, the latest creatinine, all these, and the insulin infusion if it was going. All these could be obtained from the medication request itself, active medication request, and it can be populated here. So the nurse just has to enter only one of these parameters instead of entering multiple parameters, which could be cumbersome. And in the existing app that I have, if the nurse forgets to update the creatinine value, only the same creatinine value will be going on throughout the admission. But here, whatever the latest creatinine value is there will be directly pulled by the Fire server itself. And they just have to enter the feed status and then enter the CBG value and click submit. That's it. And now the doctor does the same thing, clicks on advise insulin. Right now, I have not yet integrated my AI model with this because the inference server requires a auth token, and since this doesn't have any auth workflows yet, I haven't integrated yet. But later on, I plan to do so when I'm converting it into a smart on Fire app. I would like to use the authentication workflows to connect with the inference server and get the required insulin advice for the patient. So the doctor can choose the medication, and if they have anything to say, they can type the notes here and then submit. And the notes will be visible here if it's present. So now the nurse can open the patient and they can see the advice, and they can see the notes if there are any, and then click on follow advice, and it will be marked as followed. So you can also see who has given the made the CBG entry, who had given the insulin advice, and who had administered the insulin. So that's so I have just created the most important aspect of my app's workflow in Fire, and that's something I'm happy about. There are still a lot of things I can do with this, which I will be developing in the future days to come, and I hope learning more about Fire will help me optimize these pathways better. So the here are a few links which you can find my personal website, my LinkedIn profile. The GitHub repo link is also given. Here's my startup website and the YouTube profile. So you can go through these and connect with me if you need. And let me know if there's any feedback. Thank you.